Geothermal heat pipes. Maybe you've seen them sticking out of the ground like this. They're made out of galvanized culvert pipe, which comes in a variety of sizes and lengths. They're reasonably inexpensive and readily available. This is a computer heat pipe connected to fins and used for cooling a CPU. Maybe you've seen one of these too. They work by drawing heat away, usually from the bottom up. Okay, so it's not really going to be the same because these are sealed and passive. Our geothermal heat pipes will be active with a pumped fluid, water. And they're put in the ground with a drill, drilled in the ground at the bottom of a trench that goes below the frost line. And the reason we do this is because it's cheaper and easier than dig and loop. Dig and loop is the expensive part of standard geothermal systems. Basically what you're doing here is you're digging up your backyard and you're putting a bunch of hose in a loopy method to extract the heat from below the frost line. So that's why we trench to the frost line to bury the connections to the pipes. We keep saying heat pipe, but they can be used in the summer for cooling because the earth is usually like 50 degrees and 50 degrees is cool. Hooked up to the heat pump already, it now just dumps out or evaporates heat into the earth. Let's just clarify a bit and recapitulate a little so it's clear what's really going on here. Water from a heat pump is going to be pumped into a bunch of these pipes that are in your backyard and will extract heat or cool from them depending on the season. These pipes are not going to be seen, but you can imagine them in a row like this because they're drilled into the earth at the bottom of a trench made by a trencher. And this is what it's going to look like when they're all done. And another place you're never going to see them is at the bottom of a frost wall or basement for a new building. They'd be buried, or possibly underneath the slab of the basement floor. In this picture, we have them in a frost wall excavation and connected to a cistern that would serve as a storage tank for geothermal heat or cold. We even think that this configuration could be circulated passively, that is, without power. If the temperature of the water in the cistern is less than the temperature of the earth, then thermal convection would move the earth's heat flowing through hoses and connections into the cistern for use by a standard HVAC heat pump system. And that cistern could also be made from the same galvanized culvert pipe. It could be insulated, covered in the soil, standing or lying in the basement or in the bottom of the foundation. It would make for a very low-cost water storage system. And this culvert pipe stuff has been around for quite a while, so lots of fittings and adapters are readily available to do whatever you might need to make them waterproof or make them do whatever you want them to do in this system. This is our plan for modification of our cyber garage to function as a small shop or residential dwelling even that would require heating and cooling. If it's not being used mostly for charging an electric vehicle, it can be fitted with a smaller lithium battery and be fitted with more thermal storage tanks, reducing costs and increasing its effectiveness. Fitted with a standard solar heat pump module, it would use sump pump and heat pipe geothermal to charge its culvert tanks and radiant slab floor with heat in the winter and cool in the summer. Perhaps completely independent of the grid and more economically and more affordably than ever. Okay, that's all we got on these geothermal heat pipes for now. See our website for more information and subscribe to the channel. See lots more stories about the solar heat pump module and other great innovations from Renew Science.